Assalamu alaikum everybody. Um, I'm going to share my screen. You guys should be able to see it just about now. Okay, can you see this?
Yes, sir.
Awesome, great. So once again, we will have exam next Monday. The exam would be about 1 hour 20 minutes. Okay, and we will have a class right after the exam. Okay, so we'll have a 3 hour session on the Monday. For the first 1 hour and 20 minutes you will have your exam, and after that we will have a short break. उसके बाद we will have a usual class. ठीक है? Exam के content आप लोगों को पता है? I'll see that there are 4 questions on the exam. So you have ample time to attempt them. Or syllabus is of course the counting part and the graph part. Okay, and graph part हम last time कर रहे थे, and this is where we stopped. I think we were discussing connected graphs and the diameter. Okay, the specific problem we were discussing was this one, that you know that the diameter of a graph is at least 3, or it's more than 3, and now you have to show that the complement of that graph has diameter strictly less than 3. Did anyone attempt it? Has anyone solved this problem?
Yes, sir.
Okay, can you just describe your solution?
Okay, I will try to explain my point, but I'm not really very good at that. So, I'll vaguely tell you what the idea was.
Okay,
So the
sure.
first thing was that if considering two different cases, if it is in a cyclic graph, then all of the nodes will be connected, and if it's a straight line graph, then it will be like the one that you made in the slide as well. So if
Okay.
A and E are adjacent in G, then they will not be adjacent in G complement. So that makes the distance between them 1. And uh, if you told us that the B and D are going to be important in this solution, so I assume that if B is adjacent to A, then it will not be adjacent to A in G complement, and will be adjacent, and D, which is adjacent to E, will not be adjacent to E in G complement. That makes the distance with the graph at max 2. So in every case, the distance in G complement will be at the maximum 2, which makes it less than 3. If it
Okay.
makes sense.
Okay. Is everyone convinced of the solution? Or are there any questions? Okay, let me try to sort of give you a solution. Okay. So let's start where we were. That we have a graph, and all we know is that the so what we know is that this graph has diameter diam of this graph is more than 3. Okay, so what this means is there exists a path of actually a shortest path. Okay, shortest path of length at least 4. Okay, so let this be your path. This may you have a vertex A, it goes to vertex B, it goes to vertex C, vertex D. Okay, ये 3 का length हो गया vertex D. Okay, so A, B, C, D, N, E. Okay, let this be. कोई एक path exist करता है, तो let's say कि we call that path A, B, C, D, E. So maybe E is connected to something else as well. I don't know. But this is for sure. We know that there are 4 vertices which are connected in path like this, and there is no short circuiting here. What that means is that A is not connected to B, B is not connected to D, C is not connected to E. तो ऐसे कोई short circuiting यहाँ पे नहीं हो रही. This is the shortest path that there can be. So last time I told you that the vertex B and vertex D play an important role here. And they definitely do, in at least the proof I have in mind. So consider the graph G complement. Let's use a different color. No, actually I अभी मैं आपको इसकी बात बताता हूँ. About the original graph G. Okay, so the thing is, consider about any other vertex Vi. Okay, and the question is, how is Vi connected to these vertices? We don't know, पता नहीं इनमें से किससे connected है किससे connected नहीं है, but what we know is that if this is an edge, if B is connected to Vi, then we know that Vi can't be connected to E. ये नहीं हो सकता कि ये वाला path exist करता हो. Okay? क्यों नहीं हो सकता? अगर ऐसा हो जाए तो what will happen is that we will have a shorter path from A to E. Okay? लेकिन हमने तो ये कहा है कि the distance from A to E is 4. Okay, it can't be less than 4. But if there is a vertex Vi which is connected to B and also connected to E, so that will mean that the path A, B, Vi, E has a short circuiting, which means the distance from A to E is 3. Okay, which is not possible. Which means कि इन दोनों edges में से कोई एक exist कर सकता है, दोनों ये exist नहीं कर सकते. Okay, both of them can't be there in the graph G. Similarly, if there is a path from, let me use a different color now because I have to. If there is a path from D to Vi, okay, अगर ये वाला आपके पास edge exist करता है, तो फिर आपके पास ये वाला edge नहीं exist करेगा, A वाला. Okay, and for the same reason, क्योंकि अगर ऐसे है तो फिर this means that there is a path from A to D which has length 2, but that's not possible, right? Because this is the shortest path from A to D and this guy has length 3. Okay, so we know that the path from A to D has length 3. It can't be smaller than this, which means for these two pink edges, I know that one of them exists, but the other one does not. Okay, ये दोनों exist नहीं कर सकते. बाकी ये वाले जो edges हैं आपके पास A to C, A to D, A to E, ये तो exist कर ही नहीं सकते, right? Because ये तो एक direct short circuiting होगी. Does this argument so far make sense? अभी हमने complement की कोई बात नहीं की. अभी हम सिर्फ ये कहा है कि अगर कोई भी vertex आप पकड़ लें, ये arbitrary vertex है, okay? For any vertex Vi, but we know is that if there is a path, there is a direct edge from B to Vi, then it's impossible to have an edge from Vi to E. Okay. Similarly, if there is an edge from D to Vi, then there is no edge from A to Vi. Does this make sense?
Yes, sir.
Yes,
Okay.
sir. Yes, sir.
Awesome. Great. What this means for complement is that इन दोनों edges में से अगर एक है, हो सकता है दोनों ना हो, okay? That there is a possibility कि original graph में ये दोनों edge exist ना करते हो. But what I know for sure is that कि इनमें से at least एक तो exist नहीं करता. Okay? What that implies for complement is that कि वो एक edge original graph के complement में ज़रूर exist करेगा. Okay? So let me try to make the complement graph. So there is an A, there is a B. अब A से B edge नहीं होगा. Okay? There is a C, there is a D, and there is a E. Okay? A से B original graph में था तो अब नहीं होगा. Okay? Let me use black color for the edges. But what I know is that there must be an edge from A to C. Okay? क्योंकि original graph में नहीं था तो यहाँ पे होगा. There must be an edge from A to D, and there must be an edge from A to E. Okay? B से C original graph में edge है तो वो अब यहाँ पे नहीं होगा, which means B to D होगा और B to E होगा. Okay? C to D नहीं होगा और C to E होगा. Okay? तो ये तो direct edges हैं जो A, B, C, D, E के दरमियान होंगे. इससे हमें कोई बहुत ज़्यादा इंफॉर्मेशन नहीं मिली, बट व्हाट वी नो इज दैट फॉर एनी आर्बिट्रेरी वर्टेक्स वी आई, अगर उसका yeah, so what we know is that a vi या डी वी आई, इन दोनों एजेस में से कोई एक एज एग्जिस्ट करेगा. ओके क्योंकि इन दोनों में से कोई एक मिसिंग था ओरिजिनल ग्राफ में, विच मीन्स कि इन दोनों में से कोई एक एग्जिस्ट करेगा. ओके सिमिलरली ये जो बी और ई है, इन दोनों में से भी कोई एज एग्जिस्ट करेगा. ओके लेट मी ट्राई टू सिंबलाइज दिस कि ये मैंने दो लाइनें लगाई हैं, व्हाट इट मींस इज इन दोनों में से कोई एक एग्जिस्ट करेगा. ओके सिमिलरली मैं यहाँ पे 3 लाइंस से क्रॉस कर रहा हूँ, तो इसका मतलब ये है कि इन दोनों में से कोई एक एग्जिस्ट करेगा. ऑलराइट so let's consider another vertex vj. okay क्योंकि ये बात तो हमने arbitrary vertex select की है ना, तो it must be true for some other vertex vj as well. okay so vj is either connected to d or it's connected to a. okay so same thing, ये जो सारी picture vi के लिए है, the same thing is true for vj as well. okay now we need to find out what's the distance between vi and vj. what do you guys think? So हमारा claim ये है कि we want to show that this distance is less than or equal to what do we want to say? It's
4.
let me just
3.
we want to, I think it's less than 3. Diameter is less than 3. okay so we want to show that this distance is less than or equal to 2. okay it's definitely less than 3, so it must be less than or equal to 2. okay so how do we know this? So let me think about this. अब हमें ये बताएं कि
Sir, I think it will be less than equal to 3, not 2.
so the statement says that it's less than equal to 2 over
Yes.
here.
Less
okay
than equal to 2.
so let's see if we can prove it that it's less than equal to 2. okay what it means is that ये अगर आपस में neighbor नहीं है तो they must have a common neighbor. okay this is what it means. all right so let's see. Let's check the possibility that there is a neighbor in the so एक possibility तो ये है कि let's consider the possibility कि vi and vj are connected to d, so then we are done, right? So we can assume that one of them is connected to d, the other one is connected to b. okay क्योंकि इन दोनों में से अगर कोई दोनों या d से connected है या b से connected है, तो then we are done. okay so we can assume that this is the case, that मैं ऊपर वाले एज अभी assume करें कि ये वाले सारे एजेस हैं. okay कलटर हो रही है पिक्चर, तो मैं इसको दोबारा ड्रा कर रहा हूँ, और आई एम ड्राइंग इट विदाउट द एजेस जो ऊपर हमने डाले थे. okay so again I have a b c d and e. okay both vi and vj are either connected to d or a. okay अगर ये दोनों d से connected हैं तो then we are done. okay so we assume that one of them is connected to d and the other one is connected to a. so far so good.
There's just one question. Why are we even considering vi and vj? मतलब ये जरूरी तो नहीं है कि वो दोनों exist करते हो. What if don't?
So the thing is, we have to consider any two arbitrary vertices. When we say that the diameter of a graph is less than 3, it means that any pair of vertices which exist in the graph must be at distance less than 3. So we have to consider two vertices which are arbitrary. Does it make sense?
ठीक है. Okay.
Okay.
Yeah.
So we have to consider two arbitrary vertices with जिसके बारे में हमें कुछ नहीं पता. Okay, so हमने दो arbitrary vertices pick कर ली, vi and vj. So एक तो possibility ये है कि both of them are connected to D. Okay, उस case में we would be done. हमारा वो case solved है. Okay, so we only need to consider the case जिसमें one of them is connected to D, the other one is connected to A. Okay. अब let's consider the other pair B and E. उस case में one of them must be connected to B and the other one connected to E. Okay, otherwise we would be done. Okay, so let's say अब उसके लिए दो possibilities हैं कि which one of them is connected to B and which one of them is connected to E. Okay, but let's for now assume कि ऐसे है कि Vj is connected to B and Vi is connected to E. Okay. What happens in this case is we should be able to okay. Let's now, so this is the scenario जो हमें bug कर रहा है. Okay, जिसके लिए हमारे पास जो diameter वो less than 3 नहीं आ रहा. Okay, let's go back and see कि how does this play in the original graph. So this was G complement. Now let's go back to G. Okay, so in G, D and E. Okay, E. What would happen for both Vi and Vj? Vj and Vi. Okay, so Vj is connected to A and B in here, so it must be connected to D and E. Okay, or it's Vi is connected to A and B. Okay.
So what can we say about their connections to C and also about their connections with each other? मतलब
Yeah.
इसके बारे में भी कोई information I think we can.
So we are going to say something about that. अच्छा, अब एक तो बात ये है कि if there is an edge between them in the G complement, तो we would be done. Okay, तो हम assume करते हैं कि there is no edge. Okay, ठीक है. If there is no edge, तो हम assume कर सकते हैं कि जो ओरिजिनल ग्राफ है उसमें इनके बीच में एक एज होगा. ठीक है. अब देयर इज द मैटर ऑफ सी के आर दे कनेक्टेड टू सी और नॉट. सो इफ both of them are connected to C, so we would be done. So we may assume that only one of them is connected to C. Okay, not both. Okay. But what does this mean for the original graph? In the original graph, it means that at least one of them is connected to C. Okay. I don't know which one, but one of them is connected to C. Let's put this edge in pink. This is getting slightly cumbersome. Okay, now we need to somehow reach a contradiction. We need to find a contradiction here. And let's see where it is. So Vi is here, which means that Vj is connected to C here. Okay. So we have Just let me see. 1, 2, 3. What are we missing? मुझे लग रहा था कि हमें डिस्टेंस 5 का पाथ मिल जाएगा, लेकिन नहीं मिल रहा. डिस्टेंस 4 का ही पाथ मिल रहा है. So let's see. There is no new code. So this guy is connected to 3. This is you don't have much in common. This does not create any distance 5 path, does it? So this was the original picture, right? So we have a path like this. There is no short circuiting. And do you see any short circuiting? Oh, there is the short circuiting. Oh, okay. So you see, there is a path of length 3 to E now. Okay. So you can go from A to VI, VI to VJ, and VJ to E. Okay. So we have a contradiction. We found a path of length 3 to E, which was impossible. Okay. All right. So let me just summarize the proof once more. So we need to show that if the diameter of the original graph is at least 4, then the diameter of the complement must be less than or equal to 2. Okay, which means that either every pair is connected by an edge, or they are connected by a common neighbor. So we start with an arbitrary path of length 4, A, B, C, D, E. And we argue that for every vertex, we know that it must be connected to at most one of B and E, and at most one of B and D and A. Okay, and now in the complement graph, you pick two arbitrary vertex, Vi and Vj. Okay, if so they must be connected to at most one of the B and E, and at most one of D and A. Okay, so we assume that Vj is connected to B, and it's connected to A, and Vi is connected to D, and Vi is connected to E. Okay, so इस केस में इन दोनों के बीच में एज नहीं होना चाहिए कॉम्प्लीमेंट में, क्योंकि अगर एज है तो उनका डिस्टेंस वैसे ही 1 हो जाएगा. Okay, and we would be done. We assume that there is no edge there. और फिर हम ये अस्यूम करते हैं कि दे डोंट हैव अ कॉमन नेबर. इनमें से किसी जगह वो कॉमन नेबर उनको नहीं मिल रहा. ओके, क्योंकि कॉमन नेबर मिल जाएगा तो उनका डिस्टेंस लेस देन और इक्वल टू 2 हो जाएगा, एंड वी वुड बी डन. Okay, so this is sort of the only picture that can happen. But if this is the only picture, we go back to the original graph and we see that we can actually find a path of length 3 from A to E, which is a contradiction, क्योंकि हमने कहा था कि original G के अंदर A, B, C, D, E is the shortest path from A to E. Okay, but it's not shortest path in this picture, because you can go from A to VI, VI to VJ, and VJ to E. Okay, and this contradiction implies कि हमारी जो assumption थी कि VJ is only connected to these 3 of them and VI is only connected to 2 of them is wrong. They must have a common neighbor. Are we good?
Yes, sir.
Questions, people? So you need to actually sit back and think about this. Okay, the argument takes a little bit of simmering. Okay, so once again मैं दोबारा आपको टेक्निक बता देता हूँ जो हमने यूज किया टू प्रूव दिस. पहला तो दिस केस इज सिंपल. हमने ये अस्यूम किया है जो कुछ हमारे पास अवेलेबल था. हमारी assumption थी कि ओरिजिनल ग्राफ कंटेन्स अ पाथ ऑफ लेंथ 4, तो हमने वो पाथ ऑफ लेंथ 4 पिक किया है, द शॉर्टेस्ट पाथ 4 from a node A to a node E. Okay, and we named the middle nodes B, C, D. उसके बाद हमने ये कहा for any arbitrary vertex it's not possible that there is a short circuiting happening, which means that it can't be connected to both D and A and it can't be connected to both B and E. Okay, it can at most be connected to one of them, which means that in the complement it must be connected to one of them. वो जो एक मिसिंग एज है, हो सकता है दोनों एज मिसिंग हो, बट एटलीस्ट एक एज मिसिंग है ओरिजिनल ग्राफ में, इट मस्ट बी प्रेजेंट इन द कॉम्प्लीमेंट. So you take any two arbitrary vertices in the complement, they can be connected to, they must be connected to at least one of B and E. So let's call such a vertex Vj. It must be connected to either A or D. So you connect it to that. At most one of them must can be connected to C. Okay. दोनों अगर connected हैं C से, तो we get a path of length 2 between Vi and Vj. Okay. So हम proof ये करना चाह रहे हैं, ये वाला हमारा काम है जो हमने proof करना है. Okay, we need to prove that for arbitrary vertex for all Vi, Vj, two vertices in the complement graph की जो vertex set है, okay, उनमें उन दोनों का distance less than or equal to 2 होगा. Okay, so we show that अगर उनके दरमियान edge है तो we are done. Okay, तो ये वाला केस तो बहुत आसान है. दूसरा केस ये कि उनके दरमियान edge नहीं है, तो फिर this must be the picture अगर उनके दरमियान कोई कॉमन नेबर नहीं है. ओके, बट इफ दिस इज द पिक्चर, तो ओरिजिनल ग्राफ की पिक्चर शुड लुक लाइक दिस. ओके, जिसमें वी आई और वी जे के दरमियान एक एज है, और इन दीज आर द वर्टिसेस एंड हाउ दे आर कनेक्टेड टू वी आई एंड वी जे. Okay, but if this is the picture, then A is connected to one of them and E is also connected to one of them. Okay, so that's it, and that gives you the path of length 3 between A and E, which is not possible. So we reach a contradiction, and we assume that Vi and Vj must have a common neighbor if they don't have an edge in the complement. Questions, people? Let me see if I can make this argument simpler. I think there is probably a way to make this argument simpler. So I'm going to leave it. I think, but there is a way to make this argument simpler. Okay, I'm going to leave it. If you need me to do it, I'll do it in the next class. But there is a way to argue about this, probably in a simpler way. Okay.
अगर हम सारे कॉम्बिनेशन को लिस्ट डाउन कर लेना, तो वो फिर समझने में आसान हो जाता है.
Yeah, that's a possibility. Yeah. Yeah. So I was thinking on the line ke you start with the complement graph, start with Vi and Vj. Okay, agar unke darmiyan edge hai to we are done. Okay, so we assume they don't have an edge. If they are both connected to A, then we are done. Okay, and if both of them are connected to E, then we are done. Okay, so in the best case, one of them is connected to E and one of them is connected to A. But if that is the case, तो फिर in the complement graph, one of them must be connected to A and one of them must be connected to E. और since complement graph में edge नहीं था, तो original graph में edge होगा. This gives you a path of length 3. Okay, so you ignore B, C, D in this case. मेरे ख्याल में that can work. I think this will work. Okay. So once again, you start with the complement graph. अब आपके पास दो vertices हैं और आपने ये बताना है कि Vi और Vj का distance at most 2 है. Okay, एक तो केस ये है कि इनके दरमियान एज है, तो that's the simple case and we would be done. So we assume कि इनके दरमियान एज नहीं है. दूसरा केस ये है कि यू स्टार्ट विद द वर्टेक्स ए एंड वर्टेक्स ई। अब अगर ये दोनों ए के साथ कनेक्टेड हैं तो वी आर डन, ओके। और अगर ये दोनों एक ई के साथ कनेक्टेड हैं देन वी आर डन एज वेल, ओके, बिकॉज दे हैव अ कॉमन वर्टेक्स, तो उनका डिस्टेंस लेस देन और इक्वल टू 2 हो जाएगा, ओके। व्हिच मींस कि at most one of them is connected to A and at most one of them is connected to E, which implies that at least one of them is connected to A in the original graph and at least one of them is connected to E in the original graph. और original graph में एक edge यहाँ पे भी होगा, okay?
Sir,
This,
but what if they are both not connected to A and B?
then that's a great वो तो बहुत आसान तरीका है ना, वो आपके पास ये हो जाएगा कि so you have Vi and Vj, they are not connected to A and they are not connected to E. What that means is कि इन दोनों में फिर ये होगा कि ओरिजिनल ग्राफ में ये दोनों कनेक्टेड हैं ऐसे, ओरिजिनल ग्राफ में ये दोनों कनेक्टेड हैं ऐसे, okay? And this gives you a path of length 3 between A and E. Okay?
Yeah, okay.
So this one is easy. So this is probably the most interesting case. This means one of them is connected to A and the other one is connected to E, but that one is also solvable. Okay, so you have 3 cases. एक तो ये है कि they have a common neighbor in either A or E, और दूसरा केस ये है कि वो common neighbor नहीं है. At least only one of them is connected to A and the other one is connected to E. वो ये वाला केस है. और the third case is both of them are connected to A, both of them are connected to E in the original graph, and both of them are not connected to A or E in the complement graph. Okay, so 3 cases हैं. You don't need to bother about B, C, and D. I think this case, man. All right, I think enough said on this problem. Okay.